Ever wondered how Netflix knows exactly what you want to watch next? Let's explore recommendation system design, Netflix and Amazon style. This is going to be fun. We will design a system that tailors suggestions. This system will have personalized user experiences, but consider the challenges of scaling to millions. We will explore how to personalize user experiences and handle data. The heart of Netflix's recommendation engine is collaborative filtering. It leverages user similarity. Imagine matching users with similar viewing histories. This filtering identifies patterns which will predict preferences. Consider two users who both loved Stranger Things. Collaborative filtering may suggest a third show liked by one, but unseen by the other. This approach scales well but suffers from the cold start problem. Content-based filtering analyzes movie attributes. This filtering will use genres, actors, and descriptions. It recommends items similar to those a user liked before. For example, if you enjoy action movies with specific actors, content-based filtering will suggest similar titles. Content-based filtering excels when user history is limited. It needs rich metadata. The recommendation is based on previous behaviors. This method avoids the cold start problem. Netflix uses a hybrid approach. This will combine collaborative and content-based methods. This solves individual limitations. Imagine a system that uses your viewing history and movie attributes. A hybrid approach provides a more robust and personalized recommendation. The system learns from your behavior and item details. This combined strategy leads to better suggestions. The system will adapt and improve over time. This is a robust approach. Asynchronous processing decouples the recommendation engine from real-time requests, improving resilience. Let's explore how this decoupling enhances system stability. Message queues like Kafka buffer incoming user behavior data. This prevents overwhelming the recommendation engine during peak traffic periods. Consider Kafka as a high-throughput buffer, ensuring data consistency even during unexpected traffic spikes. It acts like a shock absorber. A caching layer using Redis stores pre-computed recommendations, reducing latency. Think of it as a quick access memory for popular results. To handle the massive traffic, we use Envoy Proxy as a load balancer and traffic manager, ensuring high availability and optimal performance. Envoy intelligently routes user requests, monitors backend health, and dynamically adjusts traffic flow based on real-time conditions for seamless user experience. Prometheus collects system metrics, including request latency and error rates, providing insights into system performance and helping identify potential bottlenecks proactively. We implement circuit breaker patterns to prevent cascading failures, isolating failing services, and preventing them from impacting the overall system stability effectively. To manage traffic and ensure high availability, we use Envoy as a reverse proxy. It intelligently routes requests based on server health. Envoy also provides crucial observability data, like request latency and error rates, enabling us to fine-tune our recommendation engine's performance in real time. Prometheus collects these metrics, allowing us to monitor the system's overall health and identify potential bottlenecks, such as a slow feature store query. To prevent cascading failures, we implement circuit breakers. If a service becomes unhealthy, the circuit breaker trips, preventing further requests. To handle increasing traffic, we can implement horizontal scaling, adding more recommendation service instances behind a load balancer. This distributes the load. We need to monitor the system's performance. Key metrics include request latency, throughput, and error rates. Prometheus helps with real-time monitoring. Let's wrap up. Building a robust recommendation system involves selecting appropriate algorithms, creating a solid data pipeline, and efficiently serving results. If you found this helpful, please subscribe, like, and comment on this video. Your support helps us create more educational content.